Hello, Algebra 2. Today we're going to be looking at measures of center and spread. And the first part of this lesson I think should be review because you should be familiar with different statistics that measure a typical value, or in other words, the center of a distribution of data. Spread statistics you may or may not be familiar with already, so we'll probably investigate those in a little bit more detail. And today's lesson is all going to revolve around one data set. So that data set appears over here in the left. And it looks like it's 15 different test scores. These are the scores from my AP Calc 1 class this year, so back in September. So we're going to look at this data set, measure its center different ways, measure its spread different ways, and just kind of analyze it as much as we can based on those simple statistics. Okay? So let me get this out of the way now so that we can have some room for a graphical display. You can, of course, display, is this one variable data or two variable data? We have one variable at work here, or two, or three, or four. We have one variable at work here, and that variable is percentage, right? Like what they got on the test. There's not two variables interacting with each other. So if you have a one variable situation, there's multiple ways to display that as a graph if it's numerical data. If it's numerical data, you don't want to use a pie chart or bar chart or anything like that. You can use a box and whisker plot. You might have seen those back in elementary school or in middle school. You can also use what's called a histogram. I don't know if you've seen those yet. Today we're going to look at a box and whisker plot, though. And you could also do things like use a box plot. So various ways to display it. In this lesson we're going to focus on a box plot and looking at the center statistics and the spread statistics. So let's construct our box plot by first finding the mode, median, and mean. So my class already found those. What was the mode? 65, and a lot of data sets don't have one. Two people got the same score here though, so that was 65. Of course, the mode's just the most common piece of data. What do you guys think? As a representation of what it is to be typical as a test score in my class, this year at least, was 65 a very good representation of the center or the middle? I don't think it was, right? Like the mode a lot of the time is not the best option, so it's kind of the least commonly used measure of center. So the median, to find that of course by hand, which you want to be able to do, you want to line up your data in order. So I already did that up here, so it's a little bit small, but you can see that I have my data ordered from least to greatest. And to find it, you just cross off from either side, right? So you go so one at a time, then you just keep going until you find the center that way. Looks like this time the center is 85.5, so that's my median. What if you had two values left here when you kept crossing off? How would you find the median then?
You add them and divide by 2.
So two different notations for the mean, x bar or mu. You guys gave me the sum of the test scores, divide by 15, and you get 82.56. What are the units here technically? Percent, and I can put that on all of these, right? So I'm just going to erase those little notes right there. So we'll find the spread statistics here in a minute. I think we're going to graph these by creating a box and whisker plot. So the first thing we'll create our box and whisker plot with is the median statistic. So we'll go 85.5%, and we'll draw the middle of our box for our box and whisker plot right there. So about 85, and I'm just going to kind of eyeball this. So I'm going to say about right here is the center of my distribution, at least according to the median. So the median represents 50% of the data being below and 50% of the data being above, right? So what else do I need for a box and whisker plot? Because I know some of you are familiar with it. I need what are called the quartiles. In fact, the median is otherwise known as quartile 2. It's the middle quartile, it's quartile 2. So I need quartile 1 and I need quartile 3. So let's put that, they aren't really center statistics, but I'm just going to put them over here with our data. Maybe I'll put them right up here. So what is quartile 1 and what is quartile 3? I already know that quartile 2 is the median. So to find quartile 1, you take the median of where the median is and the beginning. In other words, that'll be where 25% of the data is below. And quartile 3 will be symmetrically on the other side where you have 75% of the data being below you. So if I have all my data laid out here, it's pretty easy to find. I just go from here to here and go chop. chop, chop, and right there. So what's between 68 and 82?
75.
75? Ooh, and it's real easy to, like, am I supposed to include this when I start that chopping process? Wouldn't that affect us? That's real easy to mess up. So let's go ahead and put this data in our calculator and just make sure we get it right. We want to be checking our work with our calculator and learning how to do that today as well. So go ahead and put your data in list 1 of your calculator, and then I'll tell you where to go from there. So I'm going to go ahead and do that. Put it in my calculator in list 1. So I'm going to clear out what was in there prior and go ahead and plug in my data points. You don't have to have them in order or anything like that. It's a nice thing, it saves some time.
That's 62.
I have a mistake? Let me know if you see one. And you can quickly check to see if you have 15 entries or 15 is the dimension of this vector, this list vector. Okay, I do. So how do you get all of these summary statistics at once? You can go ahead and press Stat, go over to Calculate, just where our regressions models were that we were just using recently, and you can go one variable statistics. We only have one variable, tell it which list, list 1. And it'll give you a whole bunch of stuff all at once. You can see there's our average that we had there. There's a few different things with sums. These we're going to get to in a minute, so we'll come back to those. You can see it says N, it gives you the min, it gives you quartile 1, it gives you the median, it gives you the max, all that stuff. So what we were trying to do is find the quartiles, right? We weren't sure whether we needed to include this or not. Tough call. Do we need to or not? No. They got 68, right? So what you're supposed to do to find it when you have one middle thing is go right here. If you have 2 and you take the average, you start with that middle thing that was the average and you go from there. That's easy to forget. Not a huge big deal, so there's a check. So do, and it's right there. So there's quartile 1. I'm going to put that down as one of my statistics as well. It's not really a statistic of center, it's the center of centers.
68, yeah.
Oh, is it 68? My bad. Thank you. Okay, and quartile 3, if you do it from the other side and go like this, you get 97, just like they got. Okay, so now I'm going to plot those as the other edges of my box on my box and whisker plot. So 97 is going to be about right here, and 68 is going to be about right here, and I can form my box. So the box represents the middle 50% of data, right? Because it goes from 25% to 75%. So that tells you what it's like to be a typical spread away from your center of the median. That's a typical spread. Of course, the spread goes farther than that, right? That's only the middle 50%. It's the typical spread. So we can go and get the rest by finding the max and min. So the min was 23.5, which is way down here, and draw our whisker. And the max is 115, which is pretty close up here, about right there maybe, just kind of guessing. And there's my plot. It's also a good idea to label these as like what they actually are, right underneath, just for reference. What was that? 85.5 and 68. Now, I'm not going to draw this whisker yet. Why is that?
Because 23.5 is an outlier.
23.5 may or may not be something called an outlier. So an outlier is a really strange or unusual piece of data. Today we're also going to learn how to detect outliers in 2 different ways. Okay? So before we get to deciding whether or not that thing is a really strange or unusual thing, I think we need to address what our spread statistics are. And we pretty much already have one of them on the board. So the one I already have on the board is this thing called IQR. What does that mean, guys? Interquartile range. That kind of says it all. If these are the quartiles, the interquartile range is the distance between the big ones, Q3 and Q1. So let's write that down for our notes in case you don't know. It's going to be Q3 minus Q1, which in this set of data is going to be 97% minus 68%, 29%. So that's this one way to measure the spread, how much spread there is in my class's Unit 1 tests. Okay? There's other ways to measure spread as well. One of the crude ones is just range. Range really doesn't tell you very much. IQR is a little bit better. Standard deviation, in a lot of cases, is even better than that. In my AP Stats class, we use standard deviation on a daily basis almost. So IQR we use fairly often, but not as much. And that really depends on the type of data that you have, and we're going to need to learn more about the shapes and stuff in another lesson to decide. So today we're just looking at the different options that we have. So 29% is a good number for the spread. Another good number for the spread comes from the standard deviation. So how do you get the standard deviation? Well, here's how you get it. Standard deviation, I'm going to call it SD. Turn this off for just a moment. Do it below though. Standard deviation is going to be the sum. This is the Greek letter meaning sum, of course.
Oh yeah, I remember the equation.
How's it go?
I don't remember. I just know there's a...
So remember, we're trying to figure out how far apart stuff is, right? That's the point of spread. A word for that is deviation. How far things deviate from one another. It's a good word choice to know, not just for math, but for other subjects as well. So I'm going to look at each piece of data, each x sub I, or individual piece of data. Here's some new notation as well, and man, it's good down the road. So each x sub I, I'm going to look at each piece of data. I'm going to find the distance. Distance in math we know in Algebra 2 is subtraction. I'm going to see how far apart it is from the average. And then, some of them are going to be, the average was what, 82, so about right here. Or in our picture up here, the average is going to be somewhere right here, right? There's x bar. So some of them are going to be really far away, like that one way down there at 23.5, or this one at 115. So they're going to have large deviations from the center. Some of them are going to be pretty close, like 80 or 82. But when we create the standard deviation, we don't want the positive ones up here, because we're going to get a positive distance up here, aren't we? To interact with and cancel out the negative ones down here. We want to add up all the deviations and look at each piece of data's, each datum's individual contribution. We want to add all of those up. We don't want the negatives and positive canceling each other out. So instead of just doing this, we go ahead and square it. All right. And then just kind of like when we find an average to begin with, we've got to, once we get that sum, we've got to divide it by something to bring it back to just size, because we added up each thing's deviation. So this will kind of give us like the average deviation if we divide it by n. Now some of you may have seen standard deviations formula in the past, and you might see an n minus 1. But right now I'm going to ignore that n minus 1 thing when we just introduce this, okay? Where that comes from is a little bit subtle. So today we're just going to think just like an average and divide by n, okay? And the last thing you'll need to do is you'll need to get rid of that squared, because we squared things to make sure we didn't have any negative numbers so that everything would be positive. So how do you get rid of square root? So we'll come back in and square root everything at the very end. So I'm going to write this out by hand a little bit for a couple pieces of data, and then we're just going to take the number out of our calculator. Why? Because we have 15 and this calculation would get very large. When you're doing your assignment, for me at least, you have some small data sets where they want you to find the standard deviation. Make sure you're doing it by hand, and then you can check yourself with your calculator. You really don't understand what a standard deviation is, what it means to be a deviation from a center, unless you do it by hand a few times. That's really important when you're just starting out, okay? If you are just like taking the calculator's word for it, you're not really understanding what a standard deviation is, and oh my gosh, that's so important, like in modern civilization, to know what a standard deviation is. So anyway, let's write it out for a few terms, and then we'll just use the calculator. So what does this equal for our set of test scores? So I'm going to take each individual piece of data. The smallest one was 23.5. So I'm going to say 23.5. What's that deviation from? What's the average? 82.56. I'm going to square that, and then I'm going to keep adding up all the other ones. So I'm going to add up, what's the next one? 65 minus the average. then I'm going to keep doing that 15 times. So the last one will be what? 115. Whoever got that score did a very good job, right? Minus the average squared. So that's going to be the sum of each x sub I minus the average squared. Then we're going to take all of that and divide it by how many pieces of data do we have? 15. And then finally, once we have that, we're going to take the square root of our answer. So this formula looks ugly, but it's really built of very simple pieces. It's just a pain in the neck to do if you have quite a few pieces of data. And 15 is not that many, but even 15 is kind of a pain in the neck. So how can you get your calculator to do this? Well, we just had it a moment ago. Let's go back to our calculator. That same thing we just pressed creates all kinds of statistics at the same time. So if you have it in your list, go to Stat, Calculate, one variable statistics. And you can see the averages right there. Where is my standard deviation? There's actually two. You can see there's some sums for various purposes as well. We're not going to use those today. There's two options for the standard deviation. This thing called S and this thing called sigma. The symbol, like I taught you some new symbols for mean, the symbol for standard deviation also has two options. Those are the two options. This means sample. That's what Sx is. It's S from the sample. Mu is for the entire population, or in other words, if you have all of everything, like if you took a census of the entire United States and looked at their test scores, they'd probably do pretty bad because it's calculus. So what is the symbol for all of the standard deviation? If you're looking at everybody, that's going to be this Greek letter sigma. And sometimes it has an X subscript on it, like our calculator does. So, do I have a set of data representing all of the test scores from my class this year? Or is it just a sample of my class this year? It's my class this year. I didn't leave anybody out. So it's everybody.
I know you wish you did.
Maybe so. But it's all of my class this year, so which one should we use? This one. Now, if you've had Ms. Holloway's stats or another stats class, you probably are used to using this for most things. And that's a good reflex, because most of the time you don't have everything. So this is pretty much the one that gets used most of the time. But in this first assignment, we're going to assume for all the data sets, and they all pretty much tell you this, that you have everything. So that means you're going to use this one. Okay, so this one's everything. This one, by the way, has the divided by square root of n in it. This one has divided by the square root of n minus 1 in it. So that's a little bit different between everything and not quite everything. And there's some subtleties there. You have to know some more statistics to understand it. Don't worry about it in this assignment. Just use sigma. Okay? So there we go. If we did that calculation, we would get 20.64%. Okay, turn off my calculator. So the last thing we had to do today was decide whether that really low test score in my class was in fact so unusually low to deem it an outlier. In other words, so extreme to say, man, there was just something weird about that person. They were not typical of the class. They were very unusual. Does that make sense? For some reason, like they didn't study, they just randomly guessed, something like that. You know what I mean? Yeah, maybe. So it looks like that could be the case.
If you try.
Yes. Yes. Thank you. So it looks like that might be the case, but we're not sure. So there's two tests you can apply. When you're going to apply which test, we'll talk about next week. Right now, your problems will say, apply this test or apply that test, okay? So two ways to detect outliers. One of them is using what I call the fences. The fences way to detect outliers. It's one method. There are many. But there's two you want to know in high school. So the fences method is to create two different fences, and if a piece of data is outside the fences, it's out of bounds, and we call it really unusual. So we'll have the lower fence and we'll have the upper fence. You create them pretty much with the same idea. You have a starting place, and then you go a certain amount out using one of your spread statistics, and that's where you end up. That's where the fence gets plopped into the ground. So I'll do my fences in red. So, place you start. You guys remember, some of you have had some of this before, haven't you? Where do you start for your lower fence? Q1, quartile 1, right here in our case. And you go down that way to create the fence. You go down, in fact, 150%. I'm not going to explain why it's 150% today. You go down 150% of your spread statistic for IQR. And you see what happens. So mine is 68 minus 1.5. What's the IQR we got? Was it 29? Yeah, see where that ends up. So can you guys tell me, where's that end up? It's going to be just about minus 30 to minus 45, maybe in the 20s.
24.5.
24.5? Is that what everybody's getting?
I got 24.5 too.
Okay, sounds good. Put a unit on it, right? Percent. And then the upper fence is the same way. You just start here at quartile 3 instead, on the other edge. Instead of subtracting, you add, so you can create the fence up here. And go 150% the IQR that way. So for us, that's going to be 97 plus 1.5 times 29, which what's it end up as?
140.5.
140.5.
See, I went ahead and used
I like how you're doing that, Kevin. 140.5%. So, if I were to draw those, the upper fence would be like up here. Clearly we don't have any outliers in that direction. We didn't expect any. The lower fence, 24.5%, is like right about here. Did we have anything below that?
Yeah, 20.
Just barely, right? So we had a point right here that we were going to draw our whisker out to, but we just decided it's outside the fence. So just like you guys expected, it was super unusual, but just barely matched the criteria for that. It was just right outside the fence. So anything in here? Our spread here was big enough to say all these things wouldn't be super unusual. Okay? So how do I draw this box plot? I go like this, and then I say, where's the next value after 23? It's 65. So that's going to be like right there. Teeny. Okay? Doesn't look like we have any other outliers. We could check that on our calculator as well. Let me show you in case you're not sure. I haven't done this before on your calculator. You go to second y equals. Go to your first plot. You've got your scattered plot, line graphs. We hardly ever use line graphs. This is a histogram. We'll use that quite a bit. And you've got two different box plots options. This one shows outliers. This one doesn't. I always pick the one that shows them. Say which list you're in, and hit zoom, number 9. And there you go. There's our picture. You can see that it shows the exact same picture that we just computed by hand. Okay? So, that's one way to detect outliers. We detected one. There's another option as well. That one uses the quartiles and the IQR. So, that method relates to the median and to the IQR. These statistics are intimately related to one another. They always go together. If you use one, you better be using the other one. The mean, shocker, goes with the standard deviation. Didn't we even use X bar to create the standard deviation? So that shouldn't surprise you. But you shouldn't be mixing and matching. If you use the mean, that guy you use for spread, use the median, use the IQR to do spread. So, what's the fence detection or outlier detection method for that? We're going to say 3 standard deviations. And this is kind of vague, but that's all we're going to do for today. So this is another way to detect outliers. So, if you have an outlier that you're thinking, or value that you think might be an outlier, you say, what is that value? So I said, this guy is questionable. It might be an outlier. I could just call it X or X sub I too. You subtract the average in order to create its deviation. Right? How much does it deviate from the center? And then you divide that by the standard deviation in order to standardize it. And if what you get is bigger or equal to 3, then it's really unusual. And that's just a rule of thumb, but where this comes from has a lot of background, and basically there's about a 99.7% chance in most situations that it's unusual if it's bigger than 3. So 3 is like a rule of thumb cutoff, like, wow, that's really unusual, you know what I mean? So we'll get into that another day. So let's check our candidate outlier. What was the only thing that might be an outlier in this case? 23.5, so I'm going to stick it right there. Subtract the average, nice. Divide by what do we get for our standard deviation? Let's see what that is. Oh, and by the way, sometimes you're going to be on this side. In this case, we'll be negative, right? When we subtract, sometimes you'll be on that side of the mean. So we like to put an absolute value around this to say it really doesn't matter either way. If your magnitude is bigger than 3, you're unusual.
2.86.
So you got 2.86? So I'll take Kevin's word for it there. 2.86. I guess I'll do it in my calculator just to show anyone watching.
Well, I mean, you would get. You get a negative. Yeah.
So it's negative, take its absolute value, and you get 2.86. So according to that outlier detection test, was this guy an outlier or not?
No.
Technically no, but that's pretty close to 3, isn't it? This isn't a set in stone rule. And really you have to know something more about the data set to know which one of these techniques is more appropriate. That's what we're not going to talk about today. Today is all about looking at different techniques and being able to use the tools, not about which tool is the one you should use, okay? 2 different ways to detect outliers, 3 different ways to measure the center, those are the only ones that matter, and 2 different ways to measure the spread. So there's really a cut in this lesson. There's 2 different ways to do everything. I'll see you next time.